YouTubers to my channel of an everyday life. I'm Aspie. If you're new, hi, welcome. I'm Aspie, and I'm all about creating mental health and awareness and sharing my life stories with Asperger's syndrome and the like, along with tips and advice along the way. So if you're into any of these and many more videos that may show up, feel free to hit that subscribe button on the bottom right hand corner, and if you do so, turn on the notification bell so you don't miss any future videos and updates like these. So as you're aware, basically at this point of time, as the title reads, I'm going to be talking more about drugs awareness right now, because I felt to share this before my important project that will come to date later on, that I hope to share with you all, because I'm really passionate about mental health and versus our physical health. As well as this, or sorry, just to give you a heads up before I begin this, they'll be broken down into different parts for you guys to easily follow step by step of what I'm sharing with you all, of the different drugs I'm going to be talking about and how it affects us, and the side effects of the long term versus the short term, the uses of what they use for, the treatments hopefully, and what they do, and so on and so forth. But the very first part is going to be back to basics anyway, based on our anatomy and physiology, based on the nervous system, as well as a little bit maybe to the drugs that are involved with this nervous system. So let's begin this. There are molecules in our body obviously known as neurotransmitters, and they are obviously in constant flux throughout the brain. They're always busy sending messages to the brain with the chemicals that are being used. Manufactured and released by the millions of neurons, a human brain processes that orchestrate how we feel, act and react. Special cells called neurons are responsible for information support throughout the brain and relay this information. To relay this information, however, they use small chemicals called neurotransmitters, as mentioned, which are released from one neuron and received by another using special ducts, or receptors in this case, to recognize the neurotransmitter and pass the information onto the cell body. And again, I'll insert a clip right now to give you a full lowdown of what a synapse and neurotransmitter looks like. Yeah, we'll be looking at today at some of the major neurotransmitters I'm going to be bringing out of the brain. There are their own special receptors and a few of their other chemicals or drugs that binds them together. The nervous system in the human body comprises of the brain, spinal cord, and the nerves connecting the brain and the spinal cord to the other parts of the body. And saying this, fundamentally, the entire functional nervous system is made of a special type of cells called neurons. The working of neurons of the nervous system is based on the property of electrical excitation of these neurons and their interconnections with other neurons. Electrically excited neuron can transmit excitation to the other neurons. This capability of propagation of the excitation forms the basis of the functioning of the entire nervous system. The neurons, the nervous system is a complex network of interconnectable, excitable cells. These cells are called neurons. They are capable of transmitting electrical chemical signals when appropriately stimulated. Normally a slight negative electrical impulse, however, or potential is maintained in the neurons relative to the outside, and this is momentarily reversed during transmission of nerve impulse. The next step is your activation of a neuron cell and nerve impulses. Activation of the neuron cell and generation of nerve impulse that moves from its point of origin is known as action potential. As already mentioned, the inside of a neuron is slightly electrically negative. Moreover, the inside of the neuron is relatively deficient in the sodium ions that are positively charged, and relatively rich in potassium ions that are negatively charged, or also, I shall correct, positively charged. Moreover, normally the neuron cell membrane is not permeable to these sodium and potassium ions. However, there are specialized channels that are usually opening up during an action potential and allow for the movement of these such ions. When an action potential is initiated, sodium channels are open first, and this causes the entry of sodium into the neuron cell, and now the inside of the neuron becomes relatively positive. After this, the potassium channels open up. The potassium from inside of neuron moves out, and inside of the cell becomes negative again. All the nerve impulses are propagated in the form of this electrical activity caused by an action potential. Neurons are interconnected with each other at specialized junctions called synapses. Electrical impulse travels in a neuron is transferred to another neuron at a synapse. Transfer of signal across a synapse usually involves the release of specialized chemicals called the neurotransmitters. When an electrical impulse reaches the end of a neuron, it causes release of a neurotransmitter in the space between the two neurons. The released neurotransmitter binds to receptors on the second neurons and initiates a cascade of reactions responsible for these generating the new electrical impulses that propagates forward. Some synapses don't have neurotransmitters in some cases. In such synapses, however, the nerve terminals of the two neurons are situated very close to each other, and the electrical impulse can jump from one to another. Nerves and muscles, which is known for the neuromuscular junction. Some nerves carry signals for the contraction of muscles. The point of connection of the nerve and the muscle is known as the neuromuscular junction. The signal transmission between the nerves and muscles is somewhat similar of those to the synapses. When the electrical signal traveling in the nerve fiber reaches the terminal portion of the nerve near the muscles, it causes some release of a neurotransmitter chemical called acetylcholine. The acetylcholine binds to receptors on the muscles, and then they initiate a chain of reactions that ultimately results in the contraction of muscle. The nerve terminals are not physically connected to the muscle system. How the nervous system works as a whole, you may be questioning. The brain and the spinal cord constitutes to the central nervous system. The brain and the spinal cord are connected to other parts of the body, such as your muscles, organs, skin, etc., by nerves. These nerves, together with their neuron bodies aggregated in the ganglia outside the spinal cord, form the peripheral nervous system. The peripheral nervous system, however, is further subdivided into somatic nervous system and autonomic nervous system. Somatic nervous system carries the voluntary nerve impulses causing the contraction of the skeletal voluntary muscles in the body. Therefore, this division of the nervous system controls the movements of the body. The nerve fibers of the somatic nervous system are carried in the spinal nerves and the cranial nerves. Autonomic nervous system of the visceral nervous system is the second major subdivision of the peripheral nervous system. It's also called involuntary nervous system. It's because of it's not under control of the brain, of the consciousness. In some special cases, for example breathing, the functioning of autonomic nervous system can be slightly altered by the conscious control. The autonomic nervous system, however, has control over a variety of functions like your heart rate, respiration, sexual arousal, salivation, sweating, the size of your pupils, urination, etc. Autonomic nervous system, however, is subdivided into two subsystems: parasympathetic system and the sympathetic nervous system. As we all know, our 5 classic senses that we process: the smell, touch, taste, and what have you. However, the human body has many more different types of sensations, each with its own special receptors and nerves. Vision, hearing, taste and smell are considered special senses, and therefore the receptors are much more complex, which then compared to other sensory modalities. Various other important sensations the human body possesses are pain, balance, proprioception, which is your joint position, sense of where your hand is when your eyes are closed, muscle stretch receptors, temperature. Other than these, there are various other sensory receptors in the human body that sense variety of physiological parameters. For example, blood pressure, baroreceptors, carbon dioxide and oxygen in the blood, chemoreceptors, lung stretch, pulmonary stretch receptors, and so on and so forth. Functioning of all the sensory modalities, however, is organized on the same general outline. Thereon, there is a receptor capable of sensing a physiological parameter, and this receptor is linked to a sensory nerve that carries the information to central nervous system. The information is processed in the central nervous system and appropriate response, if needed, is sent through the nerves. Dopamine is known for pleasure, reward, and motivation. Without pleasure, we would not be here today. Eating, sex, and happiness are all the things that makes us feel good. So this is a feel-good chemical balance of the neurotransmitter. As a consequence, we seek them out. Of all the neurotransmitters in the brain, dopamine is one of the most associated with pleasure, though endorphins also plays a large part here too. Everything that makes you feel good is down to the dopamine and the effect it has on the brain. Moreover, every known addictive substance affects dopamine releases in what's known as the brain's reward pathway, the equivalent of a neurological circuit connecting experience with feeling good. Dopamine also plays a role in positive reinforcement and dependency, making a person more likely to repeat pleasurable actions and become addicted to substances that give this feeling. Regulating dopamine's effects throughout the brain are its receptors, of which are the 5 main environments, which are the D1 to the D5. Alongside pleasure, these receptors ensure the involvement of dopamine in a huge range of activities, from movement and attention to memory. Drugs such as cocaine and amphetamines lead to a sharp temporary rise in dopamine with the brain. Unfortunately, things aren't quite as simple as that. With more and more research, however, bringing out, it's becoming increasingly apparent that dopamine isn't just a happy drug, or neurotransmitter, I should say. Some research actually suggests that we shouldn't think about dopamine as a pleasure stimulator, but rather as a motivational stimulator, as it increases the person's motivation to repeat an action when it's associated with a pleasurable feeling. It also has a whole range of functions inside and outside the brain, showing just how important this little chemical is. Glutamate, what goes up. This is known as a on switch in the brain, known as the excitatory neurotransmitter. This tiny molecule does pretty much what it says on the to the T on the tin. Whatever it finds a receptor to dock with, it causes the hosting neuron to become excited. An excited nerve is one that's more likely to fire, resulting in the release of its own unique mix of neurotransmitters. Glutamate receptors are a varied bunch and can be split into 2 main families. Ionotropic receptors are so called because they are the ones that forms channels for ions to move through when the glutamate binds to them. Ionotropic glutamate receptors are MVA, which ketamine binds to and blocks its activity. Kainate and AMPA. Metabrotropic glutamate receptors act like a little more indirectly, however, chances are you're already an expert on glutamate as it crops up in foods either alone, its taste savoury, or in its flavour enhancing form, MSG. Gaba must come down, which is known as gamma aminobutyric acid, is the neurotransmitter acting as glutamate's lazy little twin. Its sole purpose being is to slow things down, dampen and inhibit nervous activity. Like glutamate, the GABA receptors are split into 2 types. GABA A receptors respond to GABA binding by allowing the flow of ions across the nerve membranes, and then the GABA B, however, on the other hand, of the receptors involve intermediaries in the process. Drugs that stimulate these receptors tend to slow the brain down, so it's no surprise that alcohol affects these receptors. Drug activating GABA receptors are found everywhere, like your liquid ecstasy or GHBs. It's become well known as a date rape drug. While other activators, such as benzodiazepines, are used in clinical texts to help people get more sleep or lessen anxiety, these drugs are easy to overdose on, so handle with care. More of these different drug types I'm going to bring out soon in the series, and will produce tolerance, i.e. you need to take more and more to achieve the very same effect and results. This means they aren't used as much as they could be clinically because they're quite dangerous. Serotonin, feeling groovy. 95% of the body's serotonin is actually in the gut, but the 5% in the brain has a big effect on the mood, a person's overall state of mind, how they feel about themselves and the external world at a point in a time. As you might expect, laying the burden of something as complex as mood, a single molecule could be oversimplifying things a little, but remarkably, this simple molecule doesn't have a big impact on the mind. The link between serotonin, however, and how you feel is down to large variety of serotonin receptors throughout the brain. Part of the reason before you of the behavioral effects of the single neurotransmitters can be so complex due to the number of different serotonin receptors types and range of effects they can have. These effects can include the levels of numerous other neurotransmitters to be increased or decreased throughout the different brain regions, like throwing a pebble in a lake for like a ripple effect, right? Serotonin obviously does this, causing a ripple effect. A lack of serotonin in the brain is associated with depression, which is why drugs called SSRIs, selective serotonin reuptake inhibitors, such as fluoxetine and Prozac, are commonly prescribed to help treat depression. Such drugs can cause an increase in the overall levels of serotonin in the brain, leading in many cases to diminished symptoms. Certain recreational drugs, however, such as your MDMA or ecstasy and LSD, known as your acids, can also stimulate serotonin receptors, leading to altered or sharing moods. MDMA has two major effects on serotonin, causing it to be released as well as blocking the receptors involved in its reabsorption, meaning high levels of serotonin remains in the synaptic cleft. This means that other receptors for serotonin continues to be active, creating the feeling of extreme happiness that MDMA is known for. However, MDMA also depletes the levels of serotonin in the brain, at least in the short term. This is likely responsible for the calm down phenomenon after the effects of the drug wearing off. Many users are left feeling down. LSD, however, has a similar structure to serotonin, meaning that it fits into and activates certain serotonin receptors. This means that brain processes related to serotonin release are constantly activated, producing feelings of happiness. LSDs also affects many other parts of the brain to produce its other psychedelic effects. Among other things, acetylcholine appears to play an important role in learning and memory. The neurons that produces this neurotransmitter, the neurons, are found in several regions of the brain, where when stimulated they release their stores of neurotransmitters on waiting neurons. But to have any effect, those neurons need to have the right receptors. And this isn't the nicotinic and muscarinic receptors. One of the most potent activators, nicotine, from reason why the cigarettes are so addictive to many of the ones that do smoke, allow ions to quickly pass through them when either acetylcholine or nicotine binds to them. Muscarinic receptors, however, on the other hand, from the term muscarine, a receptor stimulant and poison extracted from certain mushrooms, act on a slower time frame than the nicotinic receptors. One of the most common blockers of the muscarinic receptors is atropine, a natural compound found in certain plants such as deadly nightshade or mandrake. There's no doubt that the brain responds to cannabis, right? The question is, why would the brain involve the ability to bind this drug? In fact, the active component of the cannabis plant, THC, tetrahydrocannabinol, is a natural mimic of compounds that the human body actually makes its own. This group of THC-like chemicals made within the body are endocannabinoids. These are fatty chemicals able to move freely between cells until they find their receptors CB1, CB2. Once these are activated, a number of pathways are activated, resulting in a diverse array of effects, from reduced experience of pain to movement to the digestive tract, as well as having an effect on the mood, which I'll link in the iCard more about the cannabis because I've already talked about this for you guys. Opioids, poppy-derived painkilling. The colourful poppy is the source of the alkaloid drug opium, an opiate literally meaning poppy tears, a property that led to the eventual discovery of the numerous opioid receptors that bind such compounds within the nervous system. One known opioid commonly used today for treatment of severe pain is morphine, after the Greek god of dreams, Morpheus. Distributed throughout the nervous system, opioid receptors OP1 to OP4 are involved in all of the calming effects that you might expect, such as pain relief and the reduction in anxiety. But these are taken to extremes by recreational drugs such as heroin, the natural partners to the opioid receptors are the endorphins released during certain activities, such as running, they're thought to be responsible for the runner's high pain and orgasm. So this will be more on the piece later. So if you want to find out more of what I'm going to share, I'm going to be sharing the different types again as a review of these drugs, and then I'm going to bring into you guys some of the drugs that are most commonly used from everybody. So if you're into this, sit tight. In the meantime, if you've got any questions, feel free to answer them below. Feel free to also follow me on my social medias. Feel free to also like and comment, as I said, share these videos around to family and friends, because I want to bring out an awareness here. So without further ado, guys, thanks for support, thanks for watching, do love it.